Welcome to episode 5, continuation of a series on mechanics. In this episode, we are taking the question to text some of the expressions or the formulas we derive from episode 1 to 4. So, if a horizontal force of 200 Newton is just sufficient to start moving a body of mass 50 kg along a wooden floor, we are to calculate the coefficient of what? Friction. The coefficient of friction, as discussed in the previous episode, is in connection with the force and the normal reaction. So, if we can make a sketch of our object or the body here, which is weighing 50 kg, there should be a downward force, which is the weight equals to the mg, this being the surface. So that is the surface on which it is being placed. Now there will be a force applied. This force is a horizontal force. When a force is going in this direction, that means there is a friction which is preventing the body from what? Moving. This is the force. This force is just sufficient. It's just sufficient to push the body. So this is moving it forward and this is moving downward. So it is still at what? Equilibrium. Then there will be a force acting on the body upward from the earth. That is what we call what? The normal reaction. So in this case, we are having two forces explained here. The horizontal force and the vertical forces. Let's deal with the vertical forces and see. So the vertical forces, as explained in the previous episode, is the upward force and the downward force. They are all vertical to the surface. So there is a downward force and upward force. It is equal and what? Opposite. So we know that our normal reaction is equals to the weight of the body, which is going to be the mg. And in order to get the value of the normal reaction, we know the m is 50 kg. So this can be given as 50 kg times 10 meter per second square, and that will give us 500 what? Newton. It means the vertical force, the sum of the vertical force in this case, with 500 what? Newton. Let's look at the horizontal forces. So the horizontal forces is going to be the force that is pushing the object, which is just sufficient to move it, and the one that is causing it from not moving. If you apply small force onto this and there is nothing holding it, just like when you tie a balloon on a string and you blow a little air, just a small air attach it, it moves. Do you get it? But if you hang an object that is heavy, just like, I don't know what is that, the dumbbell of the boxers, what they use in training, when you go and touch it, it doesn't move. When the force you are applying to it does not outweigh the force in the object, it will still be at one place. So when it's about to move, it means the force you are applying is just sufficient to push it to be bigger than the force holding it. So we can see in and out. That make it your force equals to what? The push, or the push equals to the force. So any direction we pick it, force equals to the frictional force, or the frictional force equals to that. We can recall that if we remember from the other episode, the force is equals to the coefficient of friction times the normal reaction. Meaning I can replace this force or the friction with the coefficient, which is mu times the normal reaction equals what? P. So what should I do from here? I can find this as the coefficient will be equals to P over what? R. But this P is the force, the horizontal force which is applied to the object. And that horizontal force is what? 200 what? Newton. The normal reaction is what? 500 what? Newton. So your mu, which is the coefficient of what? Friction is going to be 2 divided by 5, right? And 2 divided by 5 will be 4/10, that is 0.4. So therefore, the coefficient of friction is going to be 0.4. It is dimensionless. It has no dimension because the Newton divided by Newton will give us what? A cancellation. All right. This is just one way by which we applied what we have learned from episode 1 to 3. All formulas we derive from there. Now we are applying them in calculation. Remember, we can also say our coefficient of friction is equals to the frictional force over normal reaction. But in this case, our frictional force is the same as what? The push or the force applied to the object. I'm sure the concept is clear. Like the video if you find it educative, share with your colleagues, leave a comment, and subscribe if we have not subscribed to the channel.